Hi everyone, welcome back to the Lavanya chemistry classes. Now we are going to look at the terms and basic concepts of thermodynamics. This topic is from Thermodynamics grade 11th. Before we are going to discuss these topics, I request all of you please subscribe and support. Now moving to the topic, William Thomson in the year 1749 invented the term thermodynamics. The word thermodynamics is derived from two Greek words, the thermos and dynamikos, which means heat and powerful respectively. And what is thermodynamics? The thermodynamics in physics is a branch that deals with heat and work and temperature and their relation to energy, radiation and physical properties of matter. That is called it as thermodynamics. The term thermodynamics is a combination of two words, thermos and dynamics. The word thermo means heat and dynamics means physical power and forces producing motion. The study of flow of heat or any other form of energy into out of a system as it undergoes a physical or chemical transformation. And the terms and basic concepts of dynamics mainly we are understand about what is a system and surroundings. A system boundary. A boundary is a closed surface surrounding as a system through which energy and mass may enter or leave the system. And surroundings means everything that interacts with the system. And system means a system is a region containing energy or matter that is separated from its surroundings and boundaries. That means a system means any specified portion of matter under study which is separated from the rest of the universe by definite boundaries are their system. And surroundings means the remaining portion of the universe other than the system chosen for study is known as the surroundings. That means, for example, the system consists one or more substances and surroundings are a simple cases. It's unusually means air or a water bath in which a system water consideration is immersed. So these are system and surroundings. And next one is systems. Types of systems. The types of systems mainly isolated system, closed system and open system. A system is said to be isolated when it can neither exchange energy nor exchange matter with its surroundings. For example, the universe is considered as isolated system. That means a system neither exchange energy nor exchange matter with its surroundings. See here, look at below the system, isolated system. The isolated system, see, a system is said to be isolated when it can neither exchange energy nor exchange matter with its surroundings. That means, so for example, a tea contained in thermos flask. Tea contained in a thermos flask is an example to understand about the isolated system. And next one is closed system. What is closed system? Which is called closed system? A system that can exchange energy but not matter with its surroundings. For example, tea contained in a closed cup. For example, see here B diagram, that means B figure. It is exchanged heat but not matter. That means a tea contained in a closed cup, that means the cup is exchanged through the heat but not energy. So the heat is observed on the outside of the cup. So it is example for closed system, a system that can exchange energy but not matter with its surroundings. It is called it as closed system. And next one is open system. What is open system? A system can exchange matters as well as energy with surroundings. That means both the energy and matter are as well as with change in surroundings. A system exchange matter as well as energy with its surroundings. It is called it as open system. For example, tea in open cup. Tea in open cup. It exchanges energy and heat as well as. That means the tea is in open cup shows us heat and energy are exchanges, both are exchanged. This shows the open system. So we are understand isolated system, closed system, open system are. Once again I repeat these systems. A isolated system, a system is said to be isolated when it can neither exchange energy nor exchange matter with its surroundings. And in a closed system, a system that can exchange energy but not matter with its surroundings. For example, tea contained in a closed cup. In open system, a system that can exchange matter as well as energy with its surroundings. It is called it as open system. These are the systems. And next one is the thermodynamic properties. What are the thermodynamic properties? How many types? And what are the examples of these properties? The thermodynamic properties are defined as a characteristic feature of a system capable of specifying the system's, that means the system's state. Thermodynamic properties are two types: extensive properties and intensive properties. The thermodynamic properties, the first one is intensive properties, are properties that do not depend on the quantity of matter. That means this property, the thermodynamic properties does not depends on the quantity of matter. The pressure and temperature are intensive properties. And next one is the in case of extensive properties, their value depends on the mass of the system. For example, volume, energy and enthalpy are extensive properties. These are thermodynamic properties. What are the thermodynamic properties? The thermodynamic properties are defined as a characteristic feature of a system capable of specifying the system's state. The thermodynamic properties may be extensive or intensive. Intensive properties are dependent and extensive properties are independent. That means, for example, the intensive properties are mainly pressure and temperature shows the intensive properties, and extensive properties volume, energy and enthalpy are the extensive properties. And next one is laws of thermodynamics. What is first law of thermodynamics, and what is second law of thermodynamics, and what is the third law of thermodynamics? The first law of thermodynamics tells that energy neither be created nor be destroyed. It can be only transferred one form to another form. The energy transfers one form to another form. That is called it as first law of thermodynamics. And second law of thermodynamics says that the entropy of any isolated system. Isolated system means energy is the system said to be isolated when neither exchange energy nor exchange matter. That is called isolated system. So the entropy of any isolated system always increases. That is called it as second law of thermodynamics. And the next one is third law of thermodynamics. What is third law of thermodynamics? The entropy of a system approaches a constant value as the temperature approaches absolute zero. So it is called it as third law of thermodynamics. The first law says that energy can neither be created nor be destroyed, and second law is the entropy of any isolated system always increases, and first law is the entropy of a system approaches a constant value temperature is absolute zero. Fourth law of thermodynamics. If two thermodynamic systems are in thermal equilibrium with a third system separately or in thermal equilibrium with each other, that is called it as the zeroth law of thermodynamics. And next one is entropy is the measure of the number of possible arrangements the atoms in a system can have. The enthalpy is the measurement energy in a thermodynamic system. So these are the terms and basic concepts of thermodynamics. Thank you for watching. Please subscribe and share and like us my videos.